My name is Nicholas Schulz, and I will be doing question 2 on page 111 of the grade 12 Advanced Functions Nelson textbook.
Alright, so to begin, we're just going to go over the question. So the question states, for a person at rest, the function p of t equals to negative 20 cos 300t plus 100 models blood pressure in millimeters of mercury, mmHg, at time t seconds. What is the rate of change in blood pressure at 3 seconds? So I've gone ahead and highlighted the important parts. So obviously our equation, p of t equals to negative 20 cos 300t plus 100, and the actual question, which is what is the rate of change in blood pressure at 3 seconds? So right away, we can see that this question relates to our trig unit, which was unit 4. As we can see, we're already using a cosine graph, so obviously this relates to that unit. Just to review right off the bat, we have our normal negative cosine graph. So as you can see already, it starts from -1 because it is a negative cosine. So we'll start at the bottom value, which is -1. It goes up at 0, it's at 90 degrees. Goes up at 1, it's at 180. Back down to 270, and then to 360. Okay, perfect. So now we know, we reviewed what our original cosine or negative cosine graph looks like. Now we can skip ahead to our actual equation and what that's going to look like. So, in our original cosine equation, we know it started from the bottom, went up, went back down. What we need to figure out now is how it's going to look. So in our original cosine equation, we started at 0, which was our origin line again. So now, we need to first look at this value over here, or as I like to call, the k value. So this k value really has one job. It just tells us how much the graph has shifted upwards. So if we started at 0, all we have to do is add 100 to it to get our number. So 0 plus 100, we can do that in our heads, is obviously 100. So now our graph's origin point, or starting point, I suppose, is 100. 100 up on the y-axis. Our second thing we can look at is our amplitude, or our A value. So this is the 20 here. We can ignore the negative for now. So the 20 is our amplitude. So the 20 will tell us how much farther up from 100 we're going and how much farther below 100 we're going. So all we have to do is add and subtract 20 from 100. So if we add 20, 100 plus 20, of course, is 120. If we do 100 minus 20, that's going to give us 80. So we have our 3 fixed points over here. So the graph cannot go above 120 and the graph cannot go below 80. Perfect. So now the tricky part is this 300 here. So what we want to do for this part is we want to figure out exactly what the 300 does. So the 300 is going to help us figure out our period, so our total time the cosine graph goes for. So we can use a simple equation. We can go the total period that we had before, which was 360, divided by, and then we get this value over here, which is 300. So if we divide these, this is obviously going to give us 1.2. So this is our number. Now, that means our new graph, the cycle will begin or repeat itself every 1.2. So our cosine graph is going to start and then it's going to stop at 1.2. We need to figure out now the points in between. So again, the graph hasn't shifted to the left or right at all, so we don't need to worry about that. But we do need to worry about just what our values are. So we know our final value where it's going to repeat itself is going to be at 1.2. So I'm just going to pencil in 1.2. So it's going to end there. Obviously it starts at 0, so this value is 0. And we know it starts from the bottom. So if we do 1.2 divided by 4, because we want 4 points, 1, 2, 3, 4, that's going to give us 0.3. So now we know each of these points is 0.3 apart from each other. And then 1.2. So now all we do is pencil a graph in. This is what our new graph is going to look like. It's going to start from 80 at 0, it's going to go up all the way up to 120, of course, and then back down to 1.2. Perfect. So now that we know exactly what our graph looks like, I have gone ahead and I have expanded our graph. So again, this is the exact same graph we just did. The amplitude is 20. You know, the graph has been increased by 100. It's just I have increased it, so increased the amount of cycles it's gone. So it's gone 3 cycles, and it ends at 3.6 seconds. So now what we got to do is we got to answer the question. So the question is, what is the rate of change in blood pressure at 3 seconds? So we got to go to 3 seconds, which is right here, and we got to see where it's at. So now, at 3 seconds, it's at exactly 120. The thing is, 120 is at the peak of the cosine graph at this point. So at the peak of the graph, the rate of change line we can draw is actually horizontal, as the line I've already drawn. It's exactly horizontal. At this point in time, the rate of change is neither going up nor it is going down, which means the rate of change at exactly 3 seconds is actually 0. And I will prove this to you right now. So now to prove to you that the rate of change is actually 0, I've already gone ahead and I've drawn a tangent. So a tangent essentially is a line that goes through the point we want to figure out the rate of change for. So this, again, the tangent I've already drawn is going through the point of 3 seconds and then 120 up here. So 3 and 120, I've drawn a tangent line. Now, to figure out the rate of change from the tangent line, all I have to do is I have to get the slope from this tangent line. So I have to pick 2 points that are actually on the line. So the 2 points that I'm going to pick that are on the line is our original point, which is 3 and 120. And then our other point I'm going to pick is the one right here. So over here is going to be 1.8 and 120. So 1.8 and 120. So now, perfect. So what I can do with this now is I can use the slope formula to figure out what the rate of change is. Now, if you plug into your calculators 0 over 1.2, you're going to get 0. Why is this? Anytime you have a 0 on the top or the numerator, your equation is always going to equal 0. So now that we found out that the slope of our tangent is equal to 0, we can come to the conclusion that actually, at 3 seconds, the rate of change of the blood pressure in millimeters of mercury at 3 seconds is actually 0. So that answers our question. Now the only step left is to write a therefore statement. It's very important to always write a therefore statement, no matter what you're doing. So we're going to finish with our therefore statement. So, the end of our problem. The second way of figuring this equation out is by plugging in an x value 0.001 to the right and 0.001 to the left. So in this equation over here, you can see I've plugged in for time. We need to find the y value for 3 seconds, so I plugged in 3.001, so that's to the right. Go through my equation, I get this number. And then on the right hand side here, I've gone 0.00 to the left. So I plugged in 2.999. You go through the equations, you figure out your y values, and of course we know our x values now. So we plug into the equation of the slope. So y2 minus y1 over x2 minus x1. You get your equation. You go, again, you'll find zeros on top. That means our slope is 0. Exact same answer, just a different way of solving it. One of the many careers that require a sinusoidal equation are Ferris wheel builders or repairmen. They have to make sure the ride is not too long or does not go too fast.